Okay, we have to talk about this is again a bit of differentiation over here. You have seen that how to differentiate sine x, you know that is cos x, okay? Then you have seen that the derivative of cos x, and that is minus sine x, okay? And then the derivative of tan x, and that is secant square x. Acha. Now there are the derivatives of their inverses as well, okay? Now, if you want to see that what is the, there are derivatives of sine inverse of x, okay? And there is the derivative of the cos inverse of x. And then there is the derivative of the tan inverse of x. Okay. Now your syllabus is not, they haven't included the derivatives of sine inverse x, cos inverse x, but there is, in your syllabus, you have to learn that what is the derivative of tan inverse of x, okay? So that is 1 over 1 plus x squared. You have to remember this. I can give you its reason that why this is like this. Okay. Let me draw a line here so that I can tell you why do we have the derivative of tan inverse x like this. And okay. Just trying to save some space here. Okay, but you have done that differentiation of implicit functions. Now see, now suppose you want to learn that why it is so. So let's say you have to find there is y, oh sorry. Yeah. Okay, now you have y equal to tan inverse of x. And you want to know what is dy by dx. Now, can I write this as tan y that is equal to x? Yes? Okay. Now, when I differentiate this using the concept of the differentiation of implicit functions, I should be allowed to write it as secant square y dy by dx, and you have 1 over here because the derivative of x is 1. Now this dy by dx is going to be 1 over secant square y. And if tan y is x, so can I say that I can change this with 1 plus tan square y? Yes? What is 1 plus tan square y? That is the secant square y. And now if I change that tan y with the x that I have over here, so then this becomes the dy by dx is 1 plus x squared. So you have to remember that this new formula in your life, that the derivative of tan inverse of x is 1 over 1 plus x squared. Now there can be, so we can have, just a minute. So there can be, now as you know that when you had to differentiate, for example, sine 2x, so it was, yeah, you people know that was 2 cos 2x. Now if you have to differentiate, let's say tan inverse of 2x. So that will be 1 over 1 plus 2x squared, and you will have the derivative of 2x over here, that is 2. It is exactly the same way as when you had to differentiate sine 2x. So it was basically cos 2x, and then you multiplied with the derivative of the angle. Now similarly, if this is tan inverse of 2x, so this is going to be 1 over 1 plus 2x squared, and then the derivative of 2x is 2. So you can write it as 2 over 1 plus 4x squared. Now suppose you have to differentiate um, tan inverse of, let's say, 5x. So you can directly say this is 5 over 1 plus 25x squared. Similarly, suppose you have to differentiate, you want to differentiate tan inverse of, let's say, k minus 2x, okay? So you are differentiating this thing. So this will be k minus 2x derivative is minus 2 over 1 plus k minus 2x whole square. Suppose you have to differentiate, you want to differentiate tan inverse of x by 2. So this will be half over 1 plus x squared over 4. And if you simplify this, this can become half into 1 over, you take the LCM here, this is 4 plus x squared, and this over goes here, okay? So this will be 2 over 4 plus x squared. So I have done many of the examples here. Now you may have something like, for example, you have to differentiate tan inverse of x squared. So that would be 1 over 1 plus x is per 4 and times 2x over here. So that is the that is how you will be differentiating the tan inverse. Now please go on to exercise 8a and try all these questions. Okay?
सर पर
Exercise.
अभी तो आपने जो लास्ट एग्जांपल की है, आपने हमें पिछले एक्सरसाइज में बताया था कि हम वेरिएबल खुद से इंट्रोड्यूस नहीं कर सकते।
वेरिएबल को क्या नहीं कर सकते?
वेरिएबल हम खुद से इंट्रोड्यूस नहीं कर सकते।
We are
पर
not
अभी जो आपने लास्ट
introducing. We
एग्जांपल
are
किया
not at
उसमें
all.
हमने
Beta, we are not at all introducing any variable over here. The thing is that I have given you an example here, like when you differentiate sine 2x, so this becomes cos 2x times the derivative of the angle. So this is happening in all these cases. Like it depends on the angle of your trigonometrical ratio here. When the angle is 2x, the derivative is 2 over here. Can you see that this
नहीं
2?
सर, जो आपने लास्ट एग्जांपल किया जिसमें आपने 2x डाला है, हम तो सिर्फ नंबर डाल सकते हैं, हम
Okay,
x की
you
वैल्यू
tell
तो
me,
नहीं डाल
एक second, बेटा आप मुझे बताओ ना, what is the derivative of sine x squared? So what would be that? Yeah. So that is basically
सर ये होगा cos x square into 2x
2x cos x squared. So we are differentiating. We are not adding or like we're not writing anything. Like I know what are you talking about. You're referring to this situation, for example, when you have to integrate something like this. This is 2x plus 1, and there is just 1 over here. So that like if you want to integrate this, you want to have a 2 over here. So you multiply this by 2 and then you divide it by 2 so that this becomes half ln 2x plus 1. So beta, you're not at all integrating over here. You're not doing anything. You're just like you're writing this 1 over this square and then you multiply it with the derivative. It is absolutely the same way. For example, if you have ln 1 plus x squared, you want to differentiate it, okay? So its derivative would be 1 over 1 plus x squared, and here you have to write the derivative of that 1 plus x squared. So you have to multiply it with the, basically the rule is, let me tell you, the rule is when you have to differentiate tan inverse of f of x. So this will be 1 over 1 plus f of x squared, and you have here f dash of x, like this. Got it, beta?
Yes,
Yes?
sir.
Okay, now it is your turn. Exercise is 8A. Now you must be onto it and you finish this.